Hello my dear learners, in this video I am going to explain about real numbers. Okay, in real numbers I am going to explain about what are the real numbers. Four topics we are discussing: what are the real numbers and how they used in our daily life. Okay, then next topic is classification of the numbers. Okay, how to classify the real numbers, and next we will look at to the flow chart of a real numbers. Next, real number representation on the number line. So here we are going to discuss about four main topics. Okay, what are the real numbers and how they are used in our daily life. Next is classification of the real number. Then we will look at into the flow chart of a real number. And next, fourth one is real number representation on number line. Okay, then what are real numbers? Real numbers are the all number which are we used in our daily life. Okay, and daily life which we are using for we will use for our financial, bank, and for measuring time, for measuring kilometers length. Okay, and measuring angles. So all we need to measure any type of the measurements, we use the numbers. So these are the numbers, and real numbers also all numbers we are represent on the number line. Okay, real numbers means all number you use in your daily life. Okay, for example, if you went to the market, if you went to the any shop, you will purchase anything and you will give some money to there. Okay, for that also, for money and for purchasing and measuring anything, we will use the real numbers. Okay, and real number, any number that can be represented on the number line is called as a real number. Okay, real that may be rational number, or that may be rational number and irrational numbers. Okay, we will look at next what are rational number and what are irrational numbers. Now look at the what are the classification of the number. Second topic is classification of the numbers. How we are classifying the numbers? When if we want to count any objects, for example, if I have here the 4 pens, I have the some pens and I have to count the how many pens. Okay, for example, if I am starting from here, it is 1 2 3 and 4, then how many pens I have here? The 4 number of pens. So for counting we are starting from the 1. Okay, 1 2 3 and 4 means I am counting from the starting number is 1. So natural numbers are nothing but all counting numbers. Okay, we call as the natural numbers. So natural number begins from the 1 2 3 4, and natural numbers we are representing with the letter n. Alphabetical letter we are representing with the n. Okay, then next, when we are adding to here, natural number begins with the 1. Then when we are adding to the 0 to any this natural numbers set, so we call those number as a whole numbers. Whole numbers we are representing with the letter w. Okay, remember this, natural number we are representing the letter with n, and whole numbers we are representing with the letter w. And whole numbers begins with the 0 1 2 3 4 means starting is 0 is a whole numbers. Okay, whole number starts from the 0 1 2. Okay, it starts from 0. The next numbers next is integer. What are integers? Here natural numbers are the all positive numbers, means start from the 1, and whole numbers are we are including the 0 to the natural number, we are getting the whole number. Okay, next look at the integer. Integer we are representing with the letter I or Z. You can, it's your wish, you can also represent with the I or Z, both letter we will use. But integer are the set of number which have positive numbers, negative numbers along with the zero. Means in a set of number we have the positive number. Okay, positive numbers are 1 2 3 4, and negative numbers means minus numbers. Okay, -1, -2, -3, -4, and like this. And along with 0 we are also adding to the positive series and negative series, we are adding the 0 to those set of numbers. So along with positive number, negative number, and along with 0 we call as a integers. Okay, now look at here 0. Look at what is the sign 0 have here. 0 doesn't have any sign, positive or negative. Means 0 is neither positive number nor a negative number. Okay, it is the main important point. Okay, it will come for the objective question also. Now what are the rational numbers? Now look at the next is rational number. What are the rational numbers? Any set of numbers we are representing or we are writing in the form of p by q. Okay, or any fractions when we are writing any number in form of p by q, means that is a fraction form. We are writing any number in the form of fraction, means p by q form, that is the, and where this q should not equal to 0. This q should not be equal to 0. Okay, this is a condition we have to remember. A set of rational numbers is set of the all numbers which can be expressed in form of p by q form. Okay, where q should not be equal to 0. It is the condition. Okay, it is very important. For example, you can take here 1 by 2, -7 by 6, 100 by 7, 0 by 5. Here all q's are some numbers, but a denominator we are taking numbers, not taking 0. Q is not equal to 0 anywhere. For example, if we are writing 7 by 0, is this a rational number? So it is not a rational number. It is undefined value. Okay, you can also say undefined, not defined. Okay, it is not defined value. 7 by 0, something by 0 is not defined. Okay, then rational numbers include terminating decimals and non-terminating recurring decimals. Okay, in rational numbers we can also classify that terminating decimals and non-terminating recurring decimals. Okay, what is mean by terminating? A terminating decimal is a decimal number that comes to end. Okay, means after decimal, if for example we have finite numbers only, after decimal we have the finite numbers. Okay, finite digits, then those number we call as a terminating decimal. For example, we are writing fraction 1 by 2 like 0.5. Here the after decimal how many digits are there? Only 1. So we can count this, that is a finite, means only one digit is there, so we can count. For example, here 20 by 8 is there, the value is 2.5 after decimal. After this decimal point how many digits are there? Only 1. So we can count that, that is a finite. If having the finite digit only after decimal, then we can call that is a terminating decimal. Look at one more example here, 0.6784 only. Okay, only after this decimal we have the how many digits? 4 digits. Okay, 4 digits. So it is also we can count. When we are counting the after digit decimal, So we call those numbers are terminating decimals. Okay, and in that non-terminating decimals also there. Non-terminating decimals means decimal number that goes on forever and does not end. Means they have infinite number. We can't count. There is not ending for the after decimal. There are so many numbers are there. So many digits are there. So we can't count. That's infinite number of digits after the decimal. Okay, simply we can say that infinite number of decimals. When having the infinite number of decimal, we call that is a non-terminating decimals. Okay, in that non-terminating we can also call recurring non-terminating decimal and non-recurring non-terminating decimals. Recurring means the number which is repeating again and again, more number of times. For example, you can look here 0.333. It is 3 is repeating, means you can also write that is 0.3 bar. This bar you can write. Okay, means here the 3 is repeating. Okay, then here 1.272727 is repeating. Okay, it is continuing, recurring. Okay, then that is you can also write 1.27 bar. Bar is on 27 because 27 is repeating again and again. So the bar should be on the 0.27. Okay, then these are the rational number only. This terminating decimal is a rational number only. Remember this. This repeating non-recurring also is a rational number. Okay, then now look at the irrational numbers. What are the irrational number? If any number, for example, if n is a natural number, okay, any natural number other than perfect square. Okay, if your n is a natural number, that should be other than perfect square. What is the perfect square? For example, if you look at 25 we can write that is 5 into 5. So it is a perfect square. For example, if you look 36, okay, you can write 6 into 6. 36 is a perfect square. If you write 16, you can write here 4 into 4. So these are the perfect square. So he is telling that the natural number, any natural number n other than this perfect square, means other than these numbers. Okay, then under root n is a irrational number. If under root n is there, so it is not, n is not a perfect square, then that we call as a irrational number. Okay, for example, root 2. For root 2, is there any perfect square is there? No. So root 2 is a irrational number. Root 3, you can also root 3 is a irrational number only. Root 4 is a, you can write 2, it is a perfect square, it is a rational number. Okay, then look at root 5. Root 5 is a not a perfect square, so it is a irrational number. Okay, then in that irrational number, here pi also it is a irrational number. Okay, 3.14 the value is there. Okay, that is a irrational number. Pi also is a irrational Okay, in that non-repeating, non-terminating decimal. Okay, the digit goes on forever without any pattern. If any number having the digit forever, it is continuous but not repeating any kind of the similar pattern. Look at, previously we are repeating here the for repeating 0.33, 3 is repeating. Okay, and here 1.2727 is repeating, means 27 is repeating. Here following the pattern 2727 is a continuous repeating. But in irrational number, non-repeating, non-terminating, means any number is not recurring, not repeating and not terminating. Okay, that we call as a non-repeating, non-terminating decimal, means any number is coming. Okay, that is pi value. Look at pi value is 3.14159265 and it is continuous. Okay, there is no end. Okay, infinite number of digits are there after decimal, so it is a irrational number. Okay, under root 2, look at 1.4142135 and not any digit is repeating and not following the any kind of pattern, so we call this as a irrational numbers. Root 3 1.73205080. Here also any after decimal not repeating and not following the any kind of the pattern, so this we call as a irrational numbers. Okay, understand? No. Now look at the next topic. Our what is the next topic after classification numbers? What is the next topic? Flow chart of real number. Okay, now look at the flow chart of real number here. Real numbers, first real numbers, in that we classifying rational number and irrational numbers. Under rational numbers we are denoting the letter with Q. Okay, that is rational numbers are nothing but the number which are writing in the form of P by Q. Okay, and what is the condition? Q should not equal to 0. So you can write here the example 1 by 2 and 1 by 4, 6 by 8, okay, 5 by 3. All this number we call as a rational number. Okay, you can take any, but your condition should be Q should not equal to 0. Okay, irrational numbers. Irrational number, just we had seen that any number that is under root, not any natural number, not having the perfect square, that is a under root number, that is a irrational numbers, means the number which are not able to write in the P by Q form. P by Q form and Q should not equal to 0, the number which are not writing. Okay, which are not in P by Q form and Q should not be equal to 0. It is a condition, you can also tell that, otherwise n is not a perfect square here. Okay, then again rational number we are again classifying that integers and non-integral numbers. Okay, we already know what are the integers. The integers are denoted with the letter I or Z. Okay, all the positive number, all the negative number along with the 0. Here the 0, look at the 0 is the center, right hand side, 0 right hand side are the positive numbers, 1 2 3 means all natural numbers. Okay, then 0 left hand side, look at 0 left hand side the negative numbers, -1 -2 -3, these are the negative numbers. Okay, positive number, negative number along with 0, we call that is a integers. Okay, then come to here non-integral rational numbers. Okay, non-integral rational number we can also write that, classify that non-integral rational numbers two parts, fractions and decimals. Okay, recurring and terminating. For example, look at here fractions 1 by 2, 9 by 5, 4 by 6 means P by Q form. Okay, anything. Then decimals means the number which are writing decimals, point. Okay, 1.5, 2.5. Okay, recurring and terminating also. Recurring means the number is repeating again after decimal, the digit is repeating again and again, so that is recurring. And terminating. Then again integers, this integer we are classified negative number, here negative number, positive numbers, these are positive numbers, and along with the 0. Okay, look at negative numbers, positive numbers, 0. Positive numbers are nothing but the natural numbers, so that natural number are nothing but counting numbers, that is denoted with the letter n, and starting begins with the 1 2 3 4. Okay, and negative numbers begins from 0 left hand side numbers, that is -1, -2, -3, and so on. Okay, and 0. Okay, 0 is a neither positive number nor negative number. Okay, when we are adding this 0 and this natural number, we are getting the whole numbers. Okay, then again this whole numbers we can classify odd numbers, even numbers, and composite numbers. Okay, again this whole number we are going to classify odd numbers, even numbers, and composite number. What are the odd numbers? When we are dividing any number. Okay, when we are dividing any number with by 2. Okay, when we are dividing any number by 2, we are getting remainder as a 1. For example, look at 3. When you are dividing 3 by 2, okay, then how much you are getting? 2 1s are 2. Here the 1, your remainder is 1. When your remainder is 1, then the number we call as a odd number. When we are dividing any number by 2 and you are getting remainder as a 0, then those number we call as a even numbers, means 2 4 6 8 10 12 14 16 and continuous, so on. Okay, here odd numbers are 1 3 5 7 9 and continuous. The composite number. Before composite number, we will look at one more point here. Positive numbers, these natural numbers also classified again the prime numbers. Okay, natural numbers begins from 1 2 3 and 4, this continuous, and those number we call as a classified prime numbers. Prime numbers are which are the prime numbers? Now look at here. What are the prime numbers? The number which having the only two factors. Okay, the number and 1 and the number itself only. Okay, what are the prime numbers? Any number having the only two factors. Okay, that is 1 and the number itself only, so we call that as a prime numbers. Okay, then look, come to the composite number. What are the composite number? The number other than prime numbers, or you can also call the number having the more than two factors. Okay, more than two factors, that number we call as a composite number. Here you have to remember the one key point. 2 is here 1 is not a prime number and not a composite number. 1 neither prime number nor composite number. This is the main point, key point, this one. Okay, 1 is neither prime number nor composite number. Okay, now look at come to our fourth topic. What we are going to discuss? Real number representation on the number line. Okay, now come to how to represent real number on the number line. We know real numbers are the natural numbers, whole numbers, integers, and rational numbers. Natural number starts from the 1. Okay, natural number starts from the 1. Draw a one number line. This symbol is a continuous, means the line is continuous. Okay, there is no ending point. Start from the 1, 2, 3, 4 and equidistant. Distance between the any two number is equal distance is there. So 1, 2, 3, 4, 5, 6, 7 and continuous, so on. Okay, then whole numbers begins from the 0 denoted with the letter is W. So we starting 0, 1, 2, 3, 4, 5, 6, 7 and so on continuous. It is this arrow mark representing the number line is continuous, go on. And the third one is the integers. Integers we denoted with the letter I and Z. Okay, then here 0. What are the integers? The number, positive number, negative number along with the 0. So look at here, all are the natural numbers. Okay, natural numbers are the positive numbers. Okay, positive numbers. And when we are adding to the natural number 0, it become whole numbers. Okay, when we are adding natural numbers 0, it is become whole number. Okay, then when we are adding the whole numbers to negative, okay, negative means -1, -2, -3, -4 and so on. So these all along with the positive, negative and 0, we call those number as a integers. Okay, then next look at the rational numbers. What are the rational numbers? Any number we are writing in the form of P by Q, and what is the condition? Q should not equal to 0. It is a main condition. Okay, then look at here, first to draw a one number line. Okay, this side integer line. Okay, 1, 0, 1, 2 and this side left side the -1, -2. If we are dividing this 0 to 1 2 parts, 1 to 2 2 parts, 1 by 2, 2 by 2, 3 by 2. Okay, this is 4 by 2. Okay, look at 1 by 2 means half of the distance between 0 and 1, that is here. Okay, means 1 by 2, equal distance 0 to 1, that is half of the distance. 3 by 2 here. Okay, then -1 by 2 is here between the 0 and -1, between center point between the 0 and -1. Here 3 by -3/2 is the center point between midpoint between -1 and -2. Okay, these are the rational numbers, number line representation of real numbers. Okay, thank you for the watching our video. Do like, share and subscribe to my YouTube channel. Thank you for your support.